Hi everyone, it's great to be here. We are going to talk with you today on how to protect your enterprise from the most emerging security breach, which is external assets connections. To be able to understand the topic, we are going to tell you a nice story. This is John. John is the Chief Information Security Officer of East America Bank. John has a very strict security strategy that contains multiple layers on all surfaces. He has network protection capabilities, cloud protection capabilities, endpoint protection capabilities, mobile security protection capabilities, and digital assets protection capabilities. Let's see the security architecture that John has established. Let's see John's security architecture. As you can see here, John has his corporate perimeter network protected by a firewall. He also has a web application firewall protecting his web application servers and database servers. He also has protection on his endpoints, on his mobile devices, on the private cloud assets of the bank, and on the public cloud assets of the bank. He even did recently various penetration testing on his web application. John knows that his web application is connecting to hundreds of connections in the internet. For example, we can see that John's web applications redirect to other websites, or in other cases, John's web application is loading flash objects from S3 addresses. It can also load strips from different domains, and it can also load files from Azure buckets. The thing is that John don't really believe that these connections can pose any risk to his web application. In other words, John is pretty happy with his security strategy. He understands it is satisfactory under the budget limits. I would like you now to meet Wang. Wang is a Chinese hacker. He is working as a freelance. Wang just got 34,000 Chinese yuan to cause major damage to his America bank. He doesn't know the source of the money, but he doesn't really care. He only wants the attack to be easy and cheap. If Wang is looking on John's probable security strategy, he understands, like any other type of hacker, that the easiest parts to attack the corporate is through the connections of the corporate. And this is being done mainly because the connections are not secured. They have no security measures on them, and nobody actually cares about the security on these connections. Therefore, Wang decided to monitor all the connections of East America Bank web application in order to find vulnerabilities. What Wang is doing now is actually put some sort of monitoring on these connections and waiting for East America Bank to do a quick mistake. Now the main question rising now is why Wang should attack through connections. And the answer is pretty simple. First of all, each web application has hundreds of connections. Most of them are vulnerable. The second thing is that on these connections there is constant changes. This means that Wang needs only one mistake on one of the connections. The third thing is that connections unfortunately has no security or very little security. And the fourth reason that Wang is going to attack through connections is that those connections are vulnerable to human mistakes. Let's see a few examples soon. Wang is very patient. Wang is now waiting for a small change in one of the connections. It can be change in the third-party DNS that the website is using. It can be change in the third-party cloud assets that the website is using. It can be a change in one of the hyperlinks that the website is using. It can be various changes that can be done. Patience pays. Wang just got mail that says very simple thing. One of the connections of the bank is now just released and has been exposed for a takeover. That's exactly what Wang waited for. If we take a look again on the security architecture of the bank, we can see that the red area is now exposed to take over by Wang. Actually, what happened is that one of the Azure buckets, which the bank is using, can now be overridden by attackers. In other words, if the web application is now using this bucket or taking files from this bucket, the attacker can override these files, and then the web application is going to use malicious files. Let's see now how such attacks can actually happen. Here we can see the logging page of the bank. When Wang is analyzing the bank, he can see that unfortunately this domain cannot load a specific JavaScript from any reason. When he further analyzes, he can see that the bank is now trying to load some sort of a script from a non-existing IP address. When he is now further research the IP address of the specific JavaScript, he can see that this specific JavaScript is coming from an Azure address that does not exist anymore. It means that it used to be exist in the past, but now no one controls this unattended domain or unattended IP address. Now it's very easy for the attacker to control this address that no one is actually controlling. So the attacker now created a domain under his control with the same name of the domain that the bank used to load scripts from. The only thing the attacker is now doing is changing the JavaScript to be a malicious JavaScript. So the JavaScript now has the same name it used to have, but now it has malicious capabilities. If I'm looking what's happening today on the bank website, when I enter the username and password, I get wrong password. After I refresh the page and after the JavaScript that is being loaded is the malicious JavaScript, the error message was actually removed because now the bank can again load the JavaScript it used to load. And the only thing being done is now that the credentials are being sent to the attackers instead of being sent to the bank. Now, of course, you can claim that this subdomain takeovers scenarios does not exist, or this is only a demo. But the real thing is that such attacks really exist. For example, we can see that Uber was actually attacked using the same method, the exact same method, and we are talking about a year and a half ago. In the second attack, Wang is now going to try to replace files that are being loaded by the website. In this case, what Wang is trying to find is files that are being used by the website. As you can see here, when Wang clicks on the registration instructions, actually a file or a PDF file is being loaded by the website. Wang sees this as an opportunity. He is now going to identify the exact bucket in which this file is stored in. After he is going to file this storage, he is going to check the bucket's configuration using the bucket's API. This can be done easily by any attacker today. What Wang is finding out is that this bucket is unfortunately misconfigured. This means that any attacker can replace any file in the bucket with his own file. So the only thing that Wang needs to do is to change the existing file in the bucket with another file with the same name, and this is exactly what he is doing. After he is doing that, if I'm a regular user that try again to click on registration instructions, what you will see here is that I just got a PDF with the same name, but only the content has changed. You can see here that actually the content was written by the attacker and the content can fill anything, starting from phishing details to any other type of details. In this case, the victim fall in trap. Now again, you can say that these scenarios rarely happens, but the real thing is that a lot of different attacks are being done using third-party cloud assets. For example, TimeHop was attacked using this specific scenario or very related scenarios that were done on their third-party cloud assets. The next attack that Wang wanted to conduct is actually attacks on the hyperlinks of the web application of the bank. In this case, Wang is just waiting for one of the hyperlinks to expire, and when one of them is expired, he can actually control them and inject malicious attack on the user that is clicking the malicious hyperlink. Let's see how this can be done. Okay, so the first phase is that the hyperlink is actually expiring. When the hyperlink is expiring, the attacker, in this case Wang, can own it. It just goes to one of the internet websites that allow you to buy IP addresses, and he actually buy the hyperlink to which the bank is now connecting. Now, what he is doing behind the scenes is actually changing the hyperlink to be a malicious hyperlink. And in such case, the next time that a user is going to click on this hyperlink, is actually going to click on the malicious hyperlink, and then bad things happen. Let's see what is happening to a user that clicks on a malicious hyperlink. So as you can see here, the user is trying to enter his username and password. Unfortunately, he has wrong password. The next thing that the user is going to do is he will try to retrieve his password by clicking on the forget password hyperlink. Unfortunately, this forget password hyperlink is now controlled by the attacker. So when he clicks on this malicious hyperlink, what actually happens is that the attacker actually changed, as you can see here above, he changed the login page from hpdemo.com to hpdemo.co. This means that actually when the user is going to go back to the landing page, it looks the exact same landing page, but it's actually .co instead of .com. And whenever the user is going to enter his username and password, the credentials were sent now to the attacker. Now, these attacks are happening all the time. And this is not something we are just saying. Okay, for example, we can see that Humana was actually attacked using very sophisticated and similar attack that managed to steal a lot of credentials from its website. From all the attacks we saw so far, we can understand that the risks to enterprises coming from third-party connections are huge. Attackers can disable the enterprise DNS. They can submit malicious commands to the network of the enterprise. They can steal credentials of the users. They can steal confidential files, and they can even conduct account takeover. The risks are huge, and John cannot ignore. From a short research we did on the 20 biggest financial institutes in the world, we found out a few very interesting stats. The first stat that we found out is that 100% of these financial institutes, and I'm talking on the biggest financial institutes, are connecting to some sort of vulnerable asset, one or more. The second stat we found is that at least one of the assets that these websites are using can be easily taken over without any hassle. The third stat we found out is that 95% of these financial institutes has a lot of security vulnerabilities coming from the connections of their websites. Now these stats are real. We check them on the biggest financial institutes in the world. And if any financial institutes have those vulnerabilities, probably any other type of enterprise has those as well. I would like to summarize everything we saw so far. I would like also to use the metaphor of time bomb. Websites connections are like time bomb waiting for explosion. Attacker needs to monitor all of the connections of the website, and then he needs only few minutes to be alone with an unwatched connection. If the corporate is not going to secure these connections, the attackers are going to monitor those and to use them when they can. Now the question rising here is how John should close these gaps. How John can really handle Wang's attacks on the connection of his website. So John needs some sort of a solution that knows to map all the assets that the website is using, all the cloud instances that the website is using, all the applications that the website is using. This should be a solution that knows to see what is known to the website and even unknown to the website, like third-party connections or different other type of connections. The solution needs to be managed ongoing, to have prevention capabilities, and to be managed from remote. The solution also has to be scopeless. It means that John cannot really invest time in monitoring all of these connections. And it should have, of course, automatic capabilities, but also human analysts that will monitor and will secure all of John's connections. And the solution called CyberPion. So CyberPion is a solution that enables any company, any enterprise, to secure all the connections going out from his website and to be monitored or to monitor all of these connections using both analysts from CyberPion and analysts from the enterprise. Let's understand very briefly how this solution works. In this case, CyberPion has some sort of a brain that connects to all the assets that the web application is using and various other addresses that the web application is using, and analyze what connections are now being attacked or being unwatched or being vulnerable to attackers. Then the brain sends back all the details to the console of the user. Now the organization, any corporate, can use this console to see what are his current assets or current connections that are not monitored, and by that secure them immediately. Now that John is using CyberPion, he can definitely be relaxed that his connections are not vulnerable anymore. All of those connections are now actually monitored and under the control of CyberPion, which means, in other words, that no attackers can take over these connections and by that attack the corporate. Thank you for joining and looking forward to see you soon.